Section 10.6, Trigonometric Ratios. Our essential question is, how do you determine which ratio to use when solving for the missing side of a right triangle? How do you determine which ratio to use? So we know three ratios, the sine, cosine, and tangent. We are going to figure out which one can help us when we're looking for a missing side of a right triangle. Okay, our first problem says use SOHCAHTOA to find x. So I'm going to write SOHCAHTOA up here. And I'm going to help you figure out which ratio we need to use. So the reference angle that we know is 51 degrees. So we know angle A. So using angle A, so we're going to use angle A. Figure out which side you know and which side you're looking for. Okay, so you know one side and you're looking for one. Okay, so when I look at this picture, remember we always identify our hypotenuse right away. The hypotenuse in this picture happens to be x, so that's the one that we're looking for. So we're looking for the hypotenuse, so I'm underlining the h's in my SOHCAHTOA. Now, the other side where the 11 is that the opposite side or the adjacent side from our reference angle 51 degrees? That one is opposite. So opposite, opposite. So the trig ratio that we're going to have to use for this problem is the sine, because that's where I underlined opposite and hypotenuse. So the sine of 51 degrees, I'm making this a proportion. So I just put a 1 under it to make it a proportion, because a proportion is a fraction that's equal to another fraction. So the sine 51 degrees, I put a 1 under it to make it look like a fraction. Sine is opposite over hypotenuse. Opposite is 11, and the hypotenuse is where the x is. So here is the proportion that we're going to solve. Now, using my calculator, the sine of 51 degrees to 4 decimal places is 0.7771. So here is my proportion. I'm going to cross multiply and divide. So 11 times 1 is 11, and then I divide by 0.7771, and x is about 14.2. So I'm rounding to the nearest tenth. Remember, with the proportion, the diagonal cross products are equal to each other. So you may have learned to write it out like this, 0.771 x equals 1 times 11, and then solve it like an equation. That will give you the same answer. Okay, my next problem. Now, my reference angle on this one is my 45 degrees. So angle A, 45 degrees. I do not have anything written on the hypotenuse on this problem, so I'm not using the hypotenuse here. So I'm going to rewrite my SOHCAHTOA so I can figure out which sides we're using. Okay, opposite is my 23, so I know the opposite side. And what I am looking for would be my adjacent side. So the ratio to use is tangent. So tangent, 45 degrees, put a 1 under it to make it a fraction. Tangent is opposite over adjacent, so 23 over x. Then use your calculator to do the tangent 45 degrees. Well, the tangent 45 degrees is 1. So look at the proportion that we have to solve here. Cross multiply and divide. 23 times 1 is 23. 23 divided by 1 is 23. So x equals 23. My next problem, my reference angle has moved. So SOHCAHTOA. Okay. Reference angle is over here, 35 degrees. The hypotenuse on this problem is the 7. The hypotenuse is the 7. It's across from the right angle. And the x is not across from my reference angle A, it is the adjacent side. Remember, adjacent is next to our angle. It's one of the sides that make that angle, that form that angle. So I've got hypotenuse and I've got adjacent. So this one is a cosine. So cosine 35 degrees, put a 1 under it, equals adjacent, which is by x, over the hypotenuse, which is 7. Cosine 35 degrees in my calculator, 0.81915, so 8192. And then I solve this, cross multiply and divide. So 7 times 0.8192 divided by 1 is approximately 5.7. Okay, my last problem. SOHCAHTOA. Reference angle, 43 degrees here at the B. My hypotenuse on this triangle is 28, and the x is the opposite side this time. So, opposite, hypotenuse, it has to be a sine. So, sine 43 degrees over 1 equals opposite, which is x, over the hypotenuse, 28. Sine 43 on my calculator, 0.681998. 0.681998. Okay, take a look at this. 4 digits. The 5th one would round it up. So if I round up a 9, it turns into a 10. So that actually rounds up the 1. So I need 0.6820. And then I can cross multiply and divide. So 0.6820 times 28 divided by 1. X is about 19.1. So these trig ratios help us find the length of a side in a right triangle. And how they're different from the Pythagorean theorem is the Pythagorean theorem requires you to know 2 of the sides, and then you can find the 3rd side. What we know on all of these problems are we know 1 side and 1 angle instead. So it's just a little bit different information, and we could use this to solve the entire triangle. Because if we needed to find all 3 sides, once we use the sine ratio on this problem to find x, we could do the Pythagorean theorem to find the 3rd side of the triangle. Or we could use another trig ratio to find that 3rd side of the triangle. We could also find the missing angle in the triangle as well, because the angles add up to 180 degrees. So trig ratios can be very useful. You should be able to write a summary now, answering your essential question. Please make sure you use complete sentences.